Hello, my name is Hank Pennypacker, and I'm here to help you get acquainted with the standard celeration chart. Over the past 40 years, I have taught hundreds, if not thousands, of teachers, college students, professionals, and even school children how to use this chart. But I've always had the benefit of having the learners right there in the room with me. This is the first time that I have tried to teach this skill electronically. But I'm sure you've had many experiences learning with this type of instruction. I'm hoping that you will make us both look good by learning the skills that I'm going to be illustrating. Before we get into the details of the chart, let's take a few minutes to discuss its history and its place in the science of behavior. The standard celeration chart has its own special place in the history of measurement in science and technology. Measurement is the act of assigning numbers and units to objects or events. Now, units of measurement in the natural sciences have three important properties. First of all, they are standard. Everyone agrees that the unit represents the dimension. For example, centimeters is the unit by which we measure the dimension of length of objects in the real world. Second, units of measurement in the natural sciences are absolute. The unit remains constant from one occasion to the next. Finally, units in the natural sciences are universal. The unit applies to all instances of the dimension. For example, the mass of any object can be expressed in grams. B.F. Skinner gave us the unit for measuring behavior, and that unit is frequency, defined as count per unit time. For example, responses per minute. Skinner also developed a means of observing frequency continuously through time. It was a device called the cumulative recorder, which you see in the picture. And here on the right side of the picture are the records that that device produces. And the way it works is very simply this. As the paper moves along, in your picture be moving down, the little pen is moving across the paper at one unit of distance, which is about a millimeter, for each event being recorded. So that as a result, it's tracing a diagonal line across the sheet of paper. And those tracings, examples of those tracings, show up in the cumulative records on the right-hand side of this picture. Now, the really important thing about this, from our point of view, is that this gave Skinner the ability to watch behavior happen dynamically, continuously through time. It was very different from the current practices of the time in which people took pictures, snapshots in effect, by making one observation of behavior, maybe over lots and lots of organisms, but only one observation of behavior frozen in time. With the cumulative recorder, Skinner was able to see the dynamic interaction of the organism with its environment through its behavior as it unfolded through time. And by that dynamic interaction and those pictures, he was able to discern some very, very important relationships and how behavior changes systematically as events in the environment occur and impact behavior. Skinner also taught us that good behavioral measurement has three properties. It is continuous, and we've already mentioned that. It is interrupted through time, just as behavior is. Second, Skinner emphasized that behavior recording should be direct. In other words, we get a direct contact with the organism through its behavior. We do not rely on judgments about the behavior. We do not rely on statistical averaging of measures taken by other people, or any of these kinds of indirect practices. We get a direct record, and in many cases, in Skinner's laboratory, the animal actually made its own record, and he could be off drinking coffee and pursuing other interests. Finally, it is complete, we get it all, and we avoid sampling whenever possible. Now, one of Skinner's premier students, Ogden Lindsley, developed an instrument for viewing frequency change over time. Now, it stands to reason that if we're interested in the application of the behavioral science, we're probably interested in the most sensitive measure possible of behavior change. And so what the instrument that Lindsley developed is essentially a picture, just as the cumulative record was a picture, of frequency changing over time. To see this more clearly, on the left-hand side of this picture is a schematic showing the relation of count and time, and the slope of that line gives you frequency. Now then, if you put frequency on the vertical axis and time along the horizontal axis, the slope is something called celeration, which is the change in frequency per unit of time. So just as frequency is change in count per unit time, celeration is the change in frequency per unit time. So the standard celeration chart flows directly out of the cumulative record. Let's begin by looking at some of the details on the edges of the chart. In the lower right-hand corner, you'll see a number of blanks with little words under them. For example, let's start with the one on the farthest right where the blank says counted. What we enter in there is a word that describes the behavior that we're counting. And we like to use active verbs. We are very, very concerned that many people try to use nouns to describe behavior, and that does absolutely no good. We are interested in verbs, active verbs, things that people do. So, for example, reads a word would be an appropriate thing to put in the counted space. Eats a bite could go there. Smokes a cigarette could go there. Tantrums, one tantrum could go there, and so forth. Immediately to the left of that is a blank with a word under it, performer. That's where you put the name of the individual whose behavior is being charted. Now between the performer and the counted, there's a blank that is a blank with no label under it, and you can insert in that any word you want that may describe or further refine your description of the individual. For example, third grade, wife, client, whatever the suitable label would be. On the line below those that we just talked about, you'll see the word charter. That is where you enter the name of the individual who is actually doing the charting. Need not be the individual whose behavior is being recorded, although it could be. And the same for the next blank says counter. That's the place where we enter the name of the individual who is counting the behavior. And remember that you have to count it in order to get a frequency. Finally, the last thing you have to do in order to get a frequency is to time, to take a timing of the period in which the behavior is being observed. And the blank to the left of the counter blank is where you enter the name of the individual who is doing the timing. So when you're all through, you have a statement. On the top row, you might have a statement that says, Billy, age 6, reads words. And this record was created by his father doing the timing, his mother doing the counting, and his sister who actually puts the data on the chart. Okay? So you have a complete little story down in the lower right-hand corner of the chart about who the players were in the immediate day-to-day contact with the behavior. Over on the left-hand side of the bottom of the chart, you'll see 3 more spaces: manager, advisor, and supervisor. The manager is an individual who sees the chart on a daily basis. Could be a teacher, could be a parent, could be a clinician working on a daily basis with a client. But that's the person, other than the behavior, him or herself, who is in closest daily contact with the behavior. To the left of the manager blank is the advisor. An advisor typically sees the behavior chart maybe once a week and may be advising 5, 10, 15 managers. So you get a kind of a supervisory hierarchy here. And then to the left of the advisor, there's a blank called supervisor, and that person is maybe one step removed, and that could be, for example, in a school, the school principal or the district curriculum coordinator. And in that case, the advisor might be the building principal, and the manager might be the teacher. In the case of a clinical setting, the supervisor might be the professional consultant who comes in monthly and checks on all the charts. The advisor might be the senior clinician on the team, and the manager might be the immediate caregiver or the behavior analyst who's in direct contact with the client on a daily basis. Obviously, down below that, you see some more blanks that you can fill in as needed. Organization will be, of course, the name of the organization where the client is, where the child is. May not be an organization. If there's just a home chart, you'd leave that blank. The idea here is to create a complete record, not only of the behavior, which will go into the chart, but also of the details of the individuals who were involved in the management of the behavior. So that later on, when you come back to look at this chart, you'll know who was involved and what their role was. Let's look now at the vertical lines on the chart. You'll see right above those blanks that we just filled in, you'll see the phrase successive calendar days. And you will see above that a series of 140 vertical lines. You'll notice that some of these lines are darker than others. If you look carefully, you'll see that every other dark line has a number under it. The first one is 0, the second one is 14. It might give you a hint as to what those dark lines are measuring, are naming. The next number is 28. What do you think the heavy vertical lines denote? If you said Sunday, you're absolutely right. The dark lines are what we call Sunday lines. And there are one of those every 14 days that's numbered, but one dark line every 7 days indicates that that is Sunday. Now, let's look at the top of that figure, and you'll see that across the top we have labeled successive calendar weeks. So you see a series of 4 weeks, and there's a 4 there. And then the next block of 4 weeks terminates with an 8, and so on across the chart until you get to 20. So the chart, the daily chart that we're talking about, shows day lines for 140 days, which is 20 weeks. Now, as kind of an additional little aid, you'll see if you look very closely on the upper left corner of that successive calendar weeks line, you'll see the little letters M, W, and F. What do you suppose those stand for? Monday, Wednesday, and Friday, and those help you find the appropriate day line when you're plotting on the chart. And you'll learn fairly quickly how far from each Sunday line. Sunday lines are kind of anchors. You'll learn how far from each Sunday line, say a Tuesday line is or a Thursday line. So, but to get you started, just look at the little MWF, and that helps guide you. There's another feature of the numbers corresponding to the day lines that's worth pointing out. If you move a given distance along that line, you are adding. For example, if you move from 14 to 21, how big a difference is that? How much did you have to add to 14 to get to 21? The answer is 7. And that distance on that line is exactly the same as the distance you get if you move from 70 to 77. So what we can conclude from this is that equal distances on this scale represent equal additions, or if we're going to the left, equal subtractions. And we call this scale, therefore, an add-subtract scale. Some people might call it an equal interval scale. But the point is that moving along this scale, the algebraic operation is addition or subtraction. Now, let's look at the horizontal lines on the chart. The count per minute scale going up the side. At first blush, these look very different from the lines across the bottom, from the day lines. The horizontal lines behave a little bit differently than the vertical lines. Why is this so? Well, let's take a look at, for example, on that scale up the left, the distance from 1 to 2. You can see that pretty clearly. Now let's look at the distance from 10 to 20 on that same scale. What can you say about those two distances? They are the same. So that means that as we go from 1 to 2 up that scale, we're moving exactly the same distance as if we went from 10 to 20. We're not adding anymore. What are we doing? We're multiplying. And what is that distance? It represents a multiply by 2. Let's look at another one. if we go from 50 to 100, what are we doing? We're multiplying again by 2. Suppose we go from 1 to 5. What are we doing on this scale? Are we adding 4? No, we're multiplying by 5. And to do that, we move the same distance as we would if we went from 100 on that scale to 500. Now, you might have noticed that as we move up the scale, the numbers get bigger very rapidly. A friend of ours, Michael Maloney, gave us a little jingle that helps us work with those numbers on the left-hand side of the chart. And the little jingle goes like this. Big numbers on the left that start with 1 tell you what to count by and what to count from. Okay, let's try it again. Big numbers on the left that start with 1 tell you what to count by and what to count from. Now let's see how this works. Start here at 1. That tells you we're going to count by ones from 1, and let's work our way up. The next line above it is 2. Next line above it is 3, and so forth up to 5. Keep counting. 6, 7, 8, 9, 10. Now we've come to 10. Big number on the left, 10, tells us what to count by. We're going to count by tens now. And what to count from, we're going to count from 10 to the next line, which is 20. Next line above that is 30, 40, and so on. The next big number after that that starts with 1 is what? It's 100. So now we're going to count by 100s from 100. And you can count along with me, 100, 200, 300, 400, 500, all the way up to 1,000. Now, if you look at the chart, you'll see that the frequency scale, that is that whole vertical axis, runs from 0.001, which is 1 in 1,000 minutes. 0.001 is 1 divided by 1,000. That turns out, incidentally, to be about 1 a day, which is very handy. And it runs all the way up to 1,000 per minute. This means that this chart can handle all human behavior that occurs at frequencies between 1 a day and 1,000 a minute. That means that we don't need to change charts when we change behaviors. And that in turn means that we have a standard and fairly universal way of picturing behavior frequencies by putting them on this chart. And they apply to any and all behavior. All right, let's see how we actually use the chart to plot behavior frequencies. The first example, we have 5 movements per minute on Tuesday of the first week. How would we go about plotting this? Well, the first thing we need to do is find the Tuesday line on the first week. Then, having found that, we find the 5 movements per minute line among the horizontal lines going across the chart. So where those two lines intersect, the vertical Tuesday line and the horizontal 5 movements per minute line, where those two lines intersect, we place a dot, as shown in that figure. How about locating the frequency of 0.02 on the 56th day line, which happens to be the 7th Sunday line? How do we do that? First step, move across the day lines till we get to the 56th line, and then move up until we get to the 0.02 line. 0.02, incidentally, is about 2 in 100 minutes. Okay, so we put our dot at where the intersection is of the 0.02 line and the Sunday line number 56, and it's shown in the figure. Now the third example, we're going to plot the frequency of 2.3 per minute on the Monday line following the 17th Sunday line. Let me say that again. We're going to find the 17th Sunday line. We're going to move over to the following Monday and put a dot on 2.3. Now wait a minute. There is no 2.3. All we have is 1, 2, 3, and so forth. So what do? Where is 2.3? Well, it will be somewhere between 2 and 3, right? This is a process we all know as interpolation. How far between 2 and 3? Closer to 2 than 3. So we locate a dot where you can see on the chart in the picture and place our dot there, and that'll be about 2.3 on the Monday following the 17th Sunday line.